Now talk about modulus of complex number. Okay, modulus of complex number, also known about it, also familiar with it, but today we'll discuss it. Okay, so how this modulus form? We know about it. The complex number is not comparable. That means z equal to x plus iy and here z1 constant x1 y1 and z2 is constant x2 plus iy2. In this way, complex number is represented. We discussed this one in previous class also. Okay, we follow previous class, then we say about that the complex number is written in complex plane. That means this one is complex plane, here x, here y, here this one is real axis, this one is imaginary axis. Okay, then what we talk about one point here x1 y1, then this one is x1, this one y1, this one represent one complex number z1. Okay, we write about it, z1 equal to x1 plus I y1, and obviously here x2 y2, x2 y2, then this one is represent as z2 equal to x2 plus r2. This one complex number. This one is the representation of complex number we also talk about in previous class. But now today discuss about modulus. Mod of z equal to what? We talk about these things. Also known about it. Who is known about it? How we develop this modulus? Why this modulus is needed for us? We are also known about it, because if we know about that things, then we are interest, we are create interest in from ourselves, and then also develop mathematics, and we also find this logic of mathematics, and we also find this magic and beauty of mathematics. Then we also develop mathematics and also interest this mathematics as one of the great subject of all. So now let's talk about why this one is needed. Okay, no why we talked about in BSc MSc level, but no why in India. We talked about one of the best colleges in BSc, Midnapur College, and obviously one of the best university in India, Banaras Hindu University in MSc. But no why in India. No, not only any of us are talk about these things. For that cause, all are dominated something. That means all are not taught well. Okay, so I'm not getting this, but now these things we get by realization or after some book reading, but this one is needed for teaching. Okay, why would that means discuss about this, why I talk about this modular subject. So this one is where this one is used. Okay, why we develop this one? If we know this one, then we understand the beauty of mathematics and what mathematics is implemented. Okay, mathematics implementation is overall world, because mathematics create everything is originated from mathematics. So mathematics is the mother of science, and obviously you call it anything about itself. Okay, now we'll talk about it, how this modulus is needed. I'm just a mathematics student, not more than that, because I'm not taught by this level. Okay, but this traditionally taughting process I also that means I also see everywhere in India. But now I also think about it, this one is needed for us. Okay, why are interest on modular subject? Because we know about that thing, z1 and z2. If two complex number, then two complex number, that means no relation is found. We'll not talk about z1 less than z2 or z1 equal to not z1 greater than z2. That means we are not talk about just equal to is possible for, that means if real part and complex part are same, imaginary part are same, then we call about z1 equal to z2 is possible. But we can't talk about this one. Okay, can't talk about this one. That means this one z1 less than z2, 1 greater than z2, we can't write in this way. So what we do, we do help of this modulus. Okay, this modulus also tell about that which are getting, that means closer to origin here or denote o. Okay, then what that means, if we write here if a equal to modulus function, then complex number to real number. Okay, we denote it in this way, f equal to this just modulus of z. Okay, then this gives one real number. Okay, that means z, if z belongs to complex number, then modulus of z real number, then we know about that real number is comparable. That means which real number is greater, which is smaller, which is larger, which is also bigger, which is, that means less in number. So we know about it at less than, greater than, and equal, all are possible in real number. So we talk about it in this, that means in this cause of that, we also talk about modulus of some complex number. Okay, so today I discuss about this, how modulus from, we are all known about it. If z equal to x plus iy, then modulus of z is defined by in this way, x square plus y square. Okay, this one is too easy. Just how is we denote it, we denote it in this way, real part square plus imaginary part square. Okay, so in this way we also denote mod z. Why mod z is needed for us, also known about it, and we also talk about why this one important, how we develop this one, and now talk about further things. Okay, of that portion. So we erase now that portion and now talk about why mod z, that means create some properties, why this one is important. So we know about that mod z equal to square root of here real z square plus imaginary z square. Okay, then obviously this implies that mod z square equal to how much, real z square plus imaginary z square. Okay, then what we talk about now, we talk about in this way, real z square less than equal to mod z square. This implies real z less than equal to mod z. Okay, same thing is here, imaginary z square less than equal to z square. This implies imaginary z less than equal to mod z. Okay, so this one is the important things about us. So we talk about in this way, real z less than equal to real z modulus less than equal to mod z, and obviously we talk about imaginary z less than equal to imaginary z modulus and less than equal to mod z. Okay, if we talk about in this way, so we write here, we write not wrong, this one is right, but if better, then this one is this in this way, this one is fascinating way. Okay, that means if minus and plus of real z obviously less than equal to mod z. So we talk about in this way, next in next line, this implies this. Okay, so we're also getting some properties of this modulus of complex number, how this complex number modulus is defined, and why this one is needed for us. Also talk about these things, and some scientists or some mathematicians are develop this one. I'll not talk about this mathematician, but who is obviously devoted their whole life for develop this, and also further proceed of this portion of complex number or complex analysis. Okay, so we are also devoted all for this mathematician or this devoted person. So we are now proceed here, we obviously remark about it and obviously minded this notice, that means these things, then we are develop mathematics fashion. And obviously if in this way taught any university, any college, anywhere, then some mathematics interest are developed in their student, and then someone obviously getting their own positions if they achieve their, that means they achieve their highest rank, or they achieve their highest position, they, if in this way something is, that means teaching procedure is in followed in this way, then not a problem at all are developed in suitable manner. Okay, now we talk about what, we talk about triangle inequality, and obviously we seen about this, we also known about a triangle inequality. How that means talk about this one, mod of z1 plus z2 less than equal to mod of z1 plus mod of z2, where z1 z2 belongs to c. Okay, then how this one is triangle inequality, and how we develop this one is too easy, we know about it, we also check about it. Okay, z1 z2 modulus of z1 okay, first we talk about z1 plus z2 equal to, we know about in previous class, x1 plus i1 plus x2 plus iy2. Then what happened, what we get x1 plus x2 plus iy1 plus y2. Okay, we get this portion. Then modulus of z1 plus z2 equal to what, square root of x1 plus x2 square plus y1 plus y2 square. Okay, then what we get from here, again we write here mod of z1 equal to square root of x1 square plus y1 square, and mod of z2 equal to square root of x2 square plus y2 square. Okay, then what we get here also, it is our portion, and going to forward discussion about that, also it is that portion, and going to forward discussion about that. Now what is this things, or now talk about in this way, here mod of z1 plus z2 equal to what, here x1 plus x2 square plus y1 plus y2 square, and then mod of z1 plus z2 square equal to x1 plus x2 square plus y1 plus y2 square. Then what we get x1 square x2 square plus 2x1 x2 plus y1 square y2 square plus 2y1 y2. And here mod of z1 equal to square root of x1 square y1 square. This implies mod of z1 square equal to x1 square plus y1 square. Mod of z2 equal to what, square root of x2 square plus y2 square, and this implies mod of z2 square equal to x2 square plus y2 square. Okay, then what happened, what we get from here, we get from here that if we here mod of z1, oh sorry, why we do it, okay we do it, but this one is not needed here. We now talk about this one, mod of z1 plus z2 equal to what, mod of z1 plus z2 equal to this one. Okay, and mod of z1 plus z2 equal to this one. Okay, then what we get, obviously we do not a problem at all, we do this one is right, but here we not right, that means we have to do this one equal to what, that means these two are not needed here I think. Okay, but we do it, we write it. Okay, then mod of z1 plus z2 whole square equal to this one, square root of x1 square plus y1 square plus x2 square plus y2 square whole square equal to this one, x1 square plus y1 square plus x2 square plus y2 square plus 2 x1 square plus y1 square to x2 square plus y2 square. Okay, then what we get here from here? Okay, so now write about it. What we get from here? We get from here that this one, or this one. Okay, and obviously we seen about it 2x1 x2 plus y1 y2 less than equal to 2 square root of x1 square y1 square x2 square y2 square. Then what we get? We get these things x1 x2 plus y1 y2 less than equal to square root of x1 square plus y1 square x2 square plus y2 square. So what we get? Okay, if we prove this one, then this one is right. Okay, so it is our portion and going to forward discussion about that. So we are now here. Okay, if this one is right, then we do mistake here. Okay, so this one equal to, so what we get this one. Okay, we get this one, then x1 y2 here x2 y1 less than equal to x1 y2 square plus y1 x2 square by 2. Okay, this one we get. Okay, then what we talk about? We talk about and we get this result. Okay, this one equal to, so simple result. We also consider this one equal to a, this one equal to b, then this one is ab less than equal to a square plus b square by 2. Okay, where ab is any number. Okay, then this one equal to what? This one we're getting from CA. Okay, we're also getting from here, where we're also getting from this one. not cm greater than equal to am, not this one, but this one is we're getting from where? Two easy consequence. Two easy consequence means what? We're also talking about a square plus b square difference to a b greater than equal to 0. This implies a difference b whole square greater than equal to 0. This implies a greater than equal to b. Sorry. So a difference b greater than square greater than equal to 0. From this we also get this one for wholly result. That means wholly result we get from where? That means we also proved this one, mod of z1 plus z2 less than equal to mod z1 plus mod z2. From where? From basic level, from basic this property of things to develop this one, and also getting what? This triangle inequality. So we now prove this triangle inequality in this fashion. Okay, and obviously geometrically we also see it so quickly. Okay, if we see geometric figure of that, then we also do it so quickly. And obviously this one is triangle law, or another that means triangle law, I think. Okay, so this one is called triangle inequality. Okay, that means vectors, some vectors, and doing some triangle law, then this one is done. Okay, from what? How this one is done? In this way, if we write z1 and if we write z2, if we z1 z2, then in this way we also develop this one equal to z1 plus z2. So we get so simply from here, this one is triangle inequality, I think. And obviously triangle rule is this one z1, it is parallel is z2, this one z2, this parallel is z2, and in this direction, so this one is opposite direction, z1 plus z2. This one is factor rule. Okay, and then obviously if you take mod, then this one is represented by in this way. Okay, so also seen about it. Now also prove another portion. Okay, what do we prove? We also prove another important property of modulus. This modulus is so important for us. Okay, how magic in modulus. So wow, this property is very important property. Okay, also prove now this property. So how we prove this one? So easily. Here mod of z1 equal to z1 plus z2 difference z2 less than equal to mod of z1 plus z2 plus mod of z2. Okay, mod z1 difference mod z2 less than equal to z1 plus z2. Okay, if we change this, if we change, that means if we change the role of z1 and z2, we get mod of z2 difference z1 less than equal to z1 plus z2. So what we get? We get from here mod of z1 difference mod of z2 less than equal to mod of z1 plus z2. So what we get? We get so sweet one. Okay, this one is the important inequality. Okay, also develop this property of modulus. So nice property of modulus. Okay, so interesting property of modulus. So what we get in this way, this one less than equal to mod of z1 plus z2 less than equal to mod of z1 plus mod of z2. This property we also develop from ourselves. Okay, this is one of the important property of modulus. We also develop this one. Then what we do so simply how we calculate this modulus. Okay, how calculate this modulus, we give some example after that. So we also discuss two important property of modulus and obviously do another property of modulus, but after some getting some example, that means after considering some example. First example we taught 1 plus 2i, simple example, mod of z equal to what? Square root of 1 square 2 square equal to what? 1 plus 4 equal to what? This one. Z equal to minus 1 plus 3i equal to mod z equal to what? Mod z equal to minus 1 whole square plus 3 square equal to 1 plus 9 equal to square root of 10. Mod z equal to minus 5 plus 10i. Then mod z equal to what? Mod z equal to minus 5 square plus 10 square equal to square root of 25 plus 100 equal to what? Equal to 125. Okay, again we talk about here z equal to 2 plus 3i, then mod z equal to what? 2 square plus 3 square equal to 4 plus 9 equal to 13. Okay, then what we get from here, we get from how to calculate this modulus. So simple way, also discuss about it. Okay, now erase that portion and going to forward discussion of that. Forward discussion is what? So simply this was done. This was done so simple way. We talk about this property with this one. This one is this property of modulus. How develop? We know about it. Z1 plus mod Z2 less than equal to mod Z1 plus mod Z2. But triangle inequality. But triangle inequality. Which inequality we discuss? Triangle inequality. So what we do about it. This one for n equal to 2. If n equal to 1, then what we get? We got mod z less than equal to mod z. Here equal to conditions are satisfied. Let z1 plus z2 plus zn minus 1 less than equal to mod of z1 plus mod of z2 plus mod of zn minus 1 be true. Then what we get? Then we get, take this one is true. Then we take what? Then we take z1 plus z2 plus zn minus 1 plus zn. Then what? Then what? This less than equal to, we consider this one a and this one b. Then this one equal to a. We write it now again. We write it equal to z1 plus z2 zn minus 1 plus zn less than equal to z1 plus z2 plus zn minus 1 plus mod of zn. less than equal to mod of z1 plus mod of z2 plus dot 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 mod of zn minus 1 plus mod of zn. Okay, so we get this power, this inequality. We develop also step by step way and use mathematical induction. Also prove this as valid for what? Valid for all and belongs to natural number. Okay, I understand about this property of modulus, one important property of modulus. Also, this one is handled in the many innovations comes from this property of modulus. Okay, now discuss another problem. Another problem are taught now, then also stop here. Another problem, another important problem also taught here. Which problem we taught? We talk about a point Z. A point Z lies on unit circle. Lies on the unit circle. Lies on the unit circle mod z equal to 1 about the origin. About the origin. Then what we get? We got from here z less than equal to mod z plus 2. Then less than equal to this one. And what we get again? We get from here that mod z less than equal to 2 greater than equal to mod of z less than 2. This equal to 1. So what we get 1 less than equal to mod z difference 2 less than equal to 3. So how we develop this? How we develop this? We develop in this way. We develop in this way. Z lies on the unit circle mod z equal to 1 about this origin, and we are also getting this inequality. Okay, 1 less than equal to mod of z minus 2 less than equal to 3. Okay, so we also do everything. So today we stop here. We also discuss about this norm and properties of this modulus and properties of this modulus. So after some times also discuss further of complex analysis. Today we stop here.